Hello, everyone, and welcome again to our series of podcasts on our HP Systems platform and its journey to the cloud, to the public cloud. Today, we have a very special guest. We have Tony Fishbeck, who's been involved since the very early days of the platform. We are talking about 20 years ago plus.
I think
He's
you
been
might want to
instrumental.
mistake me for someone else. No, I'm just kidding. 20 years.
He's been instrumental in so many aspects of the design and development of HPCC over these last 2 decades. And as you know, HPCC doesn't look anything like it was 20 years ago. And a big part of that credit goes to Tony. So I want to have Tony here. I wanted to have him tell us what he's now working on. He's been very active, adding a number of capabilities in HPCC. Many of those have to do with the journey to the cloud. Some of those have to do with improving the way dynamic ESDL works. You're probably familiar with this from previous releases and features that you probably use as well. So I don't think Tony needs any more introduction. Hey, Tony, how are you doing?
Hey, Flavio, doing great. How are you?
Thank you for being here.
It's good to be here.
So, Tony, tell us a little bit of what you're doing on HPCC nowadays. What's your core areas of interest, and what is that you're working on actively?
So, of course, as everyone knows, there's a big effort right now to get the HPCC to run in containerized cloud-based environments, Kubernetes, using Helm as the packaging manager for our processes, for our clusters. And so I've been focusing on, part of my time has been focusing on that as well. I've been changing the way we configure, for instance, ESP applications, so that it's much more streamlined. You can basically, in the bare metal environments, we used to, for instance, deploy very complex ESPs because they weren't changing over time. So we'd have 10 different configurations on one process, 10 different running on 10 different ports, but all different combinations of services and configurations and plugins and security and things like that. But that required a lot of because it was static, it required a lot of operational aspects of running the config tool, setting everything up, deploying the configuration, and just leaving it there until there were small changes, right? That doesn't work in the cloud, and in fact, it doesn't take advantage of some of the aspects of the cloud. So I've been focusing on a new way of running and configuring ESP, identifying flavors of the application, like, for instance, ECL Watch is a particular configuration. It's consisting of like 8 to 10 services. It's not a simple configuration if you look internally, but to the external user, it's one thing, and it's one very simple configuration. So, for instance, I've been working on creating applications for ESP, and it's basically pre-configured applications that you can very simply deploy. And if you overriding a few things like the Dolly address and things like that, you basically only change the things that you want to change. Everything else is defaulted.
Oh, that's very interesting. So these are some sort of I don't want to steal the term, but applets for ESP, or little self-contained components, functional components that you can deploy.
Yes. So it takes away all the complexity of deploying something that we already have. So that we deploy often, like for instance, ECL Watch for the external user. We've separated now the internal, the same services, but for the internal, like for access from the various cluster components. We have something called ECL services. So it's the same collection of services, no GUI, but it's meant for internal access so that we can lock it down, secure it better, and it'll scale differently than the ECL Watch will, or separately than the ECL Watch will. We have WSECL is now a service called, an application called ECL Queries. We have WSSQL, which is an application called SQL to ECL. Just things like that, right? So we pre-package these things, and now it becomes very, very easy. You can just basically go to a command line, say run ESP as this application, and maybe you set the Dolly IP or a couple other small little things, and it'll just start up and run. It makes it very, very easy to start up, especially in a containerized environment where you just want to override a few things. We have the Helm charts set up so that it just kicks off. The default is to kick off one of each of those services I mentioned, or applications, I should say, that I mentioned. And all it does is sets the internal port, the external port if it's accessible externally, and a few other things. And it very easily starts up. And it's really just all these applications is really just under a folder in the deployment. There's a subfolder called with the application name and then a few YAML files, right? So it just grabs that, loads up the configuration, changes whatever you've told it to change. You can do much more sophisticated. You can use YAML files to change the configuration if there's a lot of things you want to change, right? But generally, it's just a matter of changing a couple things on the command line, and you're ready to go.
So theoretically, you can point all of these deployments to some GitHub, where you have some code repository where you have your ESP application and maybe your YAML files and maybe your Helm charts, and it will auto-deploy from there? How does it work?
Absolutely. So I don't imagine that most of the HPCC users out there in the community will need to create their own ESP applications. This is a matter of we've defined the ones that most people are going to need. You just, if you're using the default, like if you're trying to run it on Docker desktop, you start up the, install the Helm chart, the default Helm chart. These just magically appear for you, right?
Wow, I love magic.
Yeah. This is really transforming the way that we deploy and work as developers with the HPCC. This whole effort. It reminds me of when we converted to open source. It's like, it's not just open sourcing. It's not just going to the cloud. It's sort of forcing you to rethink about certain things and to refactor certain things that have been on the back of your mind in the past. But not only does it force you because of the timing, but there's so much synergy out there, so much effort being put into making these things easier that you can really sort of standardize and do it the same way other people are doing it, and leverage their, the various tools that are being produced out there. It's really it's a big change in terms of sort of the entire approach, right? Not just getting into the cloud. It's refactoring the way we operate, the way we function, the way we configure.
So, but now I'm not trying to trivialize it, but at the core, ESP seems to be an application that is well suited to be loaded and run in containers because it's stateless. It doesn't have any data. Well, as far as I can think of it, right? Maybe I'm wrong. So it seems to me that it's almost a natural fit for a container type deployment. So what are the real challenges there when you started to think about containers? I don't know, things like auto-scaling or failure tolerance or something other things. Are those real challenges there?
No, we've tried our hardest throughout the years to keep it's really up to the service to be ESP itself is stateless, but it's up to the individual services to maintain that philosophy, right? And we've tried our best throughout the years for each service to do that. In-house, we might have a few services that are stateful on purpose, right? We've decided that they need to be for some reason, but that is 99% of the case. We're stateless. So it really is, like, as you say, it really lends itself to that containerized model. So there's not a lot we have to do to enable that. You have to determine the resources that's necessary, the scaling rules that are necessary for your individual service. And as I started to say before, we break up those services now. We don't put them into some monolithic process. We break them up so that they can scale independently. And it's definitely one of the easier components in terms of scaling, to figure out how it's going to work. So.
Hey, tell me a little bit about the security aspect. So as we move to the public cloud, certainly security is something that is top of mind to people today, not just because of all of recent events in the world and how cybersecurity is becoming a determinant of success or failure of companies sometimes in very large scale,
Right.
but also because the public cloud has different type of threat vectors, right? So it's not the same type of threat model that you would do in your own data center. So how are you coping with this? How is CSP adapting to this type of security model?
Right. So when I talked about moving to the cloud and how it's not just about getting into the cloud and scaling properly and everything, it's really about rethinking how we deal with some of those issues like security. And it's about benefiting from everyone else is going through the same issues. And there's so many people out there innovating around these exact topics. So we're really, in terms of security, there's a couple of aspects that we're looking at. Secrets management is one that we've always sort of had a very proprietary sort of heavy-handed mechanism for managing all of that. And there's so much synergy around that area that we're trying to take advantage of as we speak.
Well,
this is the kind of stuff I'm working on.
So
right
inside you say, well, we shouldn't have invented the wheel at the time. If there is a wheel out there, let's use whatever is there. But unfortunately, the wheel wasn't there. So we need to invent the wheel in many cases because there was no wheel.
Exactly. And so it really is a matter of things are just, we can take advantage of all those synergies. And it makes it so much, secret management and certificate authority, certificate management are both things that there's a lot of innovation out there that we can take advantage of. So for secrets, which is what one of the security related things I'm looking at now, we're taking advantage of Kubernetes secrets at that level. There's sort of two levels of secrets, right? There's the system level secrets that appear that get mounted on your pod and or exposed to environment variables, but we're not going to do that. But get mounted on your pod and you can access them. They're managed outside. That's sort of system level. But then there's sort of the vault level or application level secrets that would be more for the users of your system to be able to expose. For instance, you write a Roxy query that needs to call out to some gateway, like some vendor gateway. You need to manage those credentials or that connection string or whatever. That's more likely to be done in something like a vault. And so we're looking at integrating all of those technologies. I'm looking at creating, first of all, integrating the platform level, the system level secrets. For instance, I'm looking at ways of embedding it into a SOAP call for ECL, right? But providing it in a way that the ECL developer never actually sees the secret. It's just telling us what secret to use, and then you connect out, and so.
Yeah, and there's a pretty strong trend there where you try to, if you can, you keep secrets outside of the reach of the developers themselves or the users themselves as much as you can, right? That gives you one more level of security. If the user is compromised in some way or the client application, there is no exposure of those secrets, right?
So for us, I want to protect those layers. I want to know that there's system level that only our components can use. There's system secrets or Kubernetes secrets, let's call them, that are accessible by the ECL language itself. So for instance, you can tell SOAP use this secret, but you can't see it. But then there's secrets that are user level, right? That you can just get them and use them. There's various aspects I'm thinking through of all those levels. And then there's vault level secrets, which have the same three layers basically, right? You want to be able to get things for the vault for your component, to get them for your plugins or your functional system functions, and then for the user.
So Tony, I think this is plenty of content for what is already happening, but what's coming down the road? So what do you envision for ESP and HPCC in general for the next? So what's coming when 8.0 is released or beyond 8.0?
Right. Yeah. So one of the other projects I've been working on is streamlining our enterprise integration layer. If you look at traditional sort of enterprise integration frameworks, they're very heavy-handed. They're more about tying together, every kind of service and manipulating huge structures and processes. Whereas generally, in the ESP world, we know what the requests we're receiving from the client and what we need to send to the back end, but we need to integrate at the field level with things like security, account settings, logging, and things like that. And so we've got this streamlined process for enterprise integration where all of that stuff becomes scriptable. You can say, get the security settings for this user, check the fields, see if anything they're asking for is invalid, and abort the request if it is. Augment the request with information from the account settings so that Roxy knows how to process the request for that particular account, that particular user. Modify the response before it goes out to the user, and then modify and control the logging behavior on the back end. But all of that stuff is, I started to describe other solutions out there. All that stuff is streamlined because we're always working with the request as it goes through. We're modifying the existing object rather than making huge transformations based on external interfaces. We can really optimize it so that we tweak it as it flows through our pipeline at various stages, and it becomes a really efficient but flexible way, scriptable way of integrating with our entire environment, but doing it in a very efficient way that simply manipulates the object as it flows through.
Well, certainly it seems to me that would reduce the latency to do all of this. If you go to one of those big integration platforms, which used to be called also workflow engines, they tend to have lots of latency, many components that the request goes through or the message goes through until it gets transformed. So this would really make it a lot, I would assume, a lot faster, a lot
right.
Far lower latency and more streamlined. But the counterpart argument would be that is this something that requires changing the ESP code? So do you need to get down to C++ to recode this, or is there a way to express these transformations in a high-level type of language in ESP?
No, that's actually the kind of problem we're getting away from, right? That's the kind of problem we had in the past. So all of this uses a transformation language that's optimized for, again, existing objects. Traditionally, and let's take XSLT as an example, right? You are building a new object and manipulating the incoming object, building something new. This language that we've created allows you to, first of all, look at all of the input sources, not just the request, but the security and other things. Call functions to check if, like, let's say there's something in security that isn't provided in the object already. You can make calls into the system to ask for more security information, ask for other types of information, or do custom kinds of manipulation that are HPCC specific to fields or to the request. So it's extensible in that way. We can add functionality to this language easily, but it allows you to iterate over parts of the request. Let's say you have 5 records coming in, iterate over them, check that they're not asking or doing something that is not allowed for this particular user, add information to each record for Roxy if you wanted to, so that sort of manipulation, but all no C++, that's purely using the scripting language. We can extend it, we can add methods that'll require C++, but then it becomes part of the public, public repository of functionalities.
So this gives you the ability to do, as you said, in-place mutation of the object, of the fields in the object as it comes through. But and maybe this is taking it too far from the original core of the discussion, but isn't the fact that sometimes these fields are not strongly typed a potential problem, because you go there and you change some content in the field and then the field is no longer representing what you expected? Flexibility sometimes brings you also some risk, and how is the equation there managed?
Yeah, field typing is an interesting conversation because we've thought about a lot. I've thought about it a lot in the past, and the fact is that we've mostly benefited from not having really strong field types in terms of this is exactly what a date looks like, right? Or this is exactly what this type of field looks like. It's allowed us to put that interface into, think of it like you're interfacing plugins, right? And you want to have maximize your support for various backends. It's the same thing with queries. If we're trying to use the same interface in front of several different queries or the same data structure, we want some flexibility there. But what the scripting
on the other hand, when you pass that information, that content in that field in a format that is outside of a boundary that was originally defined for the field, the response, the behavior of the receiving part of that object might not be what you expect, right? Oh, I expected a date, and this is not a date. How do I handle it? Yes.
Right, and ECL in particular is not traditionally good at that sort of thing. But what the scripting actually does is it would allow us to start to say, okay, for this particular environment, this particular query, run this script, which has validation that's a little more specific. So the ESDL itself, the interface definition itself, is flexible, and we want it to be, so that we can plug in multiple things, but you can run one of these scripts that does some of that validation per configuration, per environment, per query. And you could say, well, I know that this query expects a particular set of values for this field. Let me make sure it's correct, get the validation out of the way before we ever deal with any other layer. So this actually helps with that, this particular enterprise integration scripting solution.
Very good. This is great. Hey, Tony, I think I don't want to make this too long for the listeners, but this has been great. I really enjoy learning what's happening in the world of ESP. Sometimes ESP is its own thing, so to me, something that's out there, I need it, but I may not know much about it, the internals, and this is fascinating. And all of this development seems to make things far easier. As I mentioned before, the argument that, well, ESP can be complicated because you need to drop down to C++ to change your functionality, that's no longer true. Now it's a myth. Yes, this is very cool.
Yeah.
And seeing that ESP is adapting very well to moving to containers as well and supporting this cloud journey, that's very useful.
It's a good time.
Yes, it is. These are very good times.
Yeah.
So, Tony, thank you very much, and I really enjoyed it. I hope the listeners enjoyed it as much as we did, and we'll see you next time. Thank you.
Thanks, Flavia.
Thank you very much.